In this example, there's a little bit of like bait planted to entice someone to mess up. People are going to see all of these familiar perfect squares and they're going to want to dive right in and start taking square roots. But we are not allowed to just go right ahead and take a square root or even apply an exponent of any type. A square root is really the 1/2 power to a sum or a difference. There's procedure, there's protocol. All right. Perfect example would be if you were doing our good old Pythagorean theorem, right? Let's scooch that down a bit. Sorry. And let's say you have a right triangle and we have 3, we have 4, and we're like, ooh, big mystery. What's that going to be? Hopefully you already know, but someone may go ahead. 3 squared plus 4 squared equals c squared. 9 plus 16 is c squared. Take the square root of both sides. Now, you might remember in geometry, you didn't really deal with that plus minus in front, and that is because when you're in geometry, more often than not, you're finding the length of a side or a distance, and we won't be in the negatives if we're speaking about that. So our negative answers are known as an extraneous solution or an extra answer that it doesn't apply to the situation, but they were still there. Okay. Anyhow, what do people want to do here? They want to make me sad. That's what they want to do. And they want to say, oh, square root of 9, 3, and square root of 16, 4. Nice. So c equals 7. That is so terrible for so many reasons. One reason is, why even square it then? Why not just add them? Take square root right now, right? Why not just add them and say that that's the hypotenuse? Reason number 1. Reason number 2 why it's terrible. This makes no sense. You cannot make a triangle, let alone a right triangle, if you are working with side lengths of 3, 4, and 7. You would have to lay the 3 and the 4 flat and then the 7 right on top of it. You're not even making a triangle. Try it. I dare you. Cut out some little strips of paper, cut some wooden dowels. Go nuts. You can't do it. All right? And next, well, those procedures that I spoke about, if we were to pick up from, I guess over here, because I already made that all yucky with that square root. We had that 9 plus 16 equals c squared. What is 9 plus 16? That's 25 equals c squared. Then, I shouldn't do it like that, but I'm being lazy. The square root on both sides, and we get c equals the square root of 25, which is 5. That makes way more sense, okay? 5 is the hypotenuse in this situation. And does 5 equal 7? No, absolutely not. Okay? So think about that the next time you are really tempted. It's wrong, okay? If it's too good to be true, if it's too easy and the steps are really, oh wow, no big deal at all, you're probably doing something incorrectly. Just letting you know, okay? So, red flags. Don't do that. Now, what am I going to do here? Well, I'm going to isolate the x squared. Again, you should notice that we have only, say, an ax squared and c, no b value. We're good to just solve by taking square roots. X squared equals, now, if someone had dove in and just started taking square roots right away over here, they would have had a 4, they would have had a 7, and maybe they'd be working with a 3 or an 11, I guess depending on how they play with their signs and when they do different things. But now we have 49 and 16. So same sign, find sum, keep same sign. 49 and 16 are both negative. We're going to find their sum. So 49 and 16 we want to add. In my head, I may take 1 from the 16 and give it to that 49. Now I'm really adding 49 is going to become 50 and 16 is going to become 15. Again, I wouldn't write this down. This is just something happening in my head. And what does that give me? 65. Same sign, find sum. So if they're both negative or both positive, add the numbers, keep same sign, means it'll be negative. Negative 65. Maybe we are even already thinking about what multiplies to give us 65. 5 definitely goes in to 65, right? Well, maybe you just count on your fingers. 5 times 10 is 50, 55, 60, 65. So 13, and both 5 and 13 are prime. So x, well, x squared becomes just x equals plus minus the square root of negative 65. Nothing to simplify here. So we're left with plus minus, well, almost nothing. I root or radical or square root 65. And there we go. So a lot of different things that we can chat about. You know, I'm not trying to take up so much of your time. Watch it in double speed. Watch it while you're getting your homework done and working through examples. But just want to point out some important stuff and places where people make mistakes and tricks for moving along and not reaching for a calculator. Okay, so check out the next example if you like it, or go to the playlist and find one that you do like. And I hope you are doing great. Adios.